Good day, everyone. I'm delighted to be the invited keynote speaker to this important conference, the Meta 2023, where it addresses lots of issues related to metaverse. And metaverse is all about connectivity. And what I'm going to talk about today is something where connectivity in healthcare and the use of problem-oriented medical record to do that connectivity, and the use of GraphQL or type GraphQL API to achieve that one. So this is my title of the invited speech, and I'm going to introduce myself very quickly. My name is Sabah Mohammed, and as you can see that I'm a full professor at Computer Science Department at Lakehead University, and I'm chairing the special interest group of connected and smart health in IEEE ComSoc. And of course, I run my own Fab Lab called Smart Health Fab Lab at Lakehead. And of course, my research is on AI, IoT, health informatics. You can connect with me on my email, which is sabahmohammed@lakeheadu.ca. Well, now, as I always do my research since 1981, that I am concerned with intelligent systems, and of course, metaverse system is kind of intelligent system too, that have to operate in large, non-deterministic, cooperative, survivable, adaptive, and partially known domains. If you like to read on my biography, this is the URL that you can see on the screen. Well, let me talk about connected health. It's a shouting thing. Everybody wants that thing to happen. Data integration of in health and connecting services will save life. And in any case, not only in emergency, but even in normal circumstances. So integration will support all wind of change in healthcare for being predictive, preemptive, personalized, problem-oriented, and participatory way. So achieving connectivity is a dream. Talking about connectivity is something that we've been talking about it in healthcare for long. We focused on electronic healthcare record. We put a lot of standards. We put a lot of money, to tell you the truth. Billions of dollars spent on standardizing EHR and things like this. But there's a missing links here. When we design or in a clinical environment, when we describe a case, there is no standard for it. At a bedside, we have no standard for that one. And if you go even to the bench, where biomedical data, pharmaceutical companies, everybody have their own standard. There's no standard, acceptable standard to connect. So we are assuming that electronic healthcare record will connect both the bedside with benchside, but that's not happening at all. Unless we connect whatever happening on the bedside with the benchside, we cannot guarantee that type of connectivity way. So, of course, you will tell me, well, the drivers of connected health now is, as you mentioned, predictive, problem-oriented, personalized, preemptive, and those are the drivers. But there are novel things that if we can have them, whatever healthcare system with that connectivity will flourish so much. Now, when we talk about those 5 P's or 5 perils that we are looking at, the most important thing that we noticed that we need to combine a clinical and IT perspective to create a structured approach to connected health. How do we connect data and devices and make that connectivity interoperable? That's a key thing, not only to achieve connectivity, but for everything like safety of information. Everything will depend on that kind of structural interoperability between data and devices. Now, you will tell me, well, did they try it before? Did they try that interoperability before? Yes, there were certain techniques. Everybody talk about them, like Semantic Web Initiative, Linked Data Initiative, Platform as Service, Enterprise Application Integration, Metadata Harmonization Technique, even Extract, Transfer, and Load tools, among the others. You see, all those connectivity either will try to fix something via file transfer, or trying to share data via shared data bases, or on using kind of remote procedure of invocation, or through some kind of messaging techniques. Those are patching techniques. They have limited success, as proven through all the years. The dream, for example, of semantic web was so strong at the beginning, but using all that metadata harmonization that is required in semantic web initiative was so difficult with the previous APIs that we've seen before. Flexibility is so difficult. So you will tell me, well, there must be some kind of light at the end of that dark tunnel of interoperability. Yes, there were some kind of achievement in that direction. For example, the ISO 11179 was one of the achievements that it called MDR, or metadata registry. You see, in that standard, they defined how matching and mapping can achieve interoperability. That's the standard. Now, if you adhere to it, most of the connectivity of data, if it follows that MDR, that will provide a big support to connectivity. That's the first light in the dark tunnel. The other achievement that we can see as a light in the end of the dark tunnel is an API called GraphQL. I'm sure you heard about it. Companies like Facebook and others made a big win when they switched to GraphQL API. Actually, they developed that API, which is very flexible at the server side, where it can harmonize interoperability between metadata based on something called mutation. So mutations and harmonization of metadata on the fly on the server is achieved via the GraphQL API. Look, that GraphQL ignited another avalanche that provide more light via Apollo Federation, because now if we can use GraphQL to harmonize metadata interoperability between application, devices, data, and so forth, can I do it on a massive direction, on a cloud, for example? Yes, we can do that via Apollo Federation, which uses GraphQL as that base. So the end of look, if I show you a snippet of how I can create an Apollo federation easily. Look, what Apollo do, I can create a server and build the schema via you see, resolvers is one of the things. That means when there is miscommunication between data, there must be some kind of resolver to do that harmonization. And of course, the way we query, so we query the data that we need only, and resolvers will resolve every mismatch. So this is how we create a server via Apollo. It's very easy, very simple. Look, GraphQL and Apollo APIs created that connectivity, and it provides us with a way to connect with data via a graph way. You see, if you look at the backend, the backend is kind of a graph. So GraphQL and Apollo connect services data and put them in a backend, which is a graph connectivity. And as you can see, graph connectivity is not a relational tabular way that we used to save the other data in the other type of techniques. So you can see that the advancement via, look, the other advancement that happened on top of that one, the GraphQL become more important. So people will say, well, why I use JavaScript? Why I do not use TypeScript? So when I use TypeScript for GraphQL, it's called GraphQL, and that is more powerful and more structural way to program. And look, if I go more in that connectivity way, I will describe one more step that provide more light for the connectivity. Is when we connect the bedside with the bench side, we need that type of imagination that make the data that is on the clinical side with the bench side to connect. How we do that? That was a dream actually, called SOAP or PUMR, or problem-oriented medical record. You see, SOAP is the way you define clinical cases at the bedside, and problem-oriented medical records will connect everything that you defined in SOAP in whatever in the bench side via a graph imagination. That imagination or dream was a dream of a person, actually a medical doctor called Lawrence Weed. And Lawrence Weed in 1968 imagined something really he didn't know how revolutionary that dream is, that changed healthcare. Everything is a graph. So this is how Dr. Lawrence Weed did design connectivity SOAP with PUMR. So what he designed is that when we want to connect everything, things like medications, of course we find a lot of information about medication from pharmaceutical point of view, lab tests, vitals, procedures, whatever case, whether it is from the bench side or it must be connected to a problem list. You can see this is a graph imagination. Now, I don't want to go into defining SOAP. SOAP means subjective, objective, assessment, and plan. This is how every medical doctor trained to describe a medical case at the bedside. Subjective mean what are the symptoms of the patient. Objectives means what are the things that the physician is imagining when he listen to those symptoms, what kind of questions. Assessment and plan is more oriented toward the physicians, where they assess the cases via lab tests and so forth, and the plan is how to treat the so SOAP is how we describe the clinical case. Look, we built at Lakehead University a prototype called GraphQL for PUMR. That means GraphQL for problem-oriented. And as you can see, we are connecting actually the whatever we describe in SOAP at the bedside with whatever in the bench side. Of course, we are using certain bench side that we can connect where they use also GraphQL, like open targets, like drug banks, and so forth. So now, when a physician, for example, describe a case in a SOAP, he can understand, for example, if there is some kind of polypharmacy, adverse events, because directly the case will be connected to other patient cases and whatever happening in the bench, and then he can easily look further than whatever in the patient electronic healthcare record to a wider sense, because he have that connectivity. Of course, what we are using for that backend, not only GraphQL, actually, we are using Neo for Java, because this is the data base, which is a graph-based database. Of course, our approach have a certain way to build it. We start with a platform approach. We use an API that is foundational, like GraphQL, Apollo, and Type GraphQL. Everything is a graph based on a problem list. We connect to FHIR, and we connect to and we produce analytics and predictive intelligence based on that one from connecting bedside and bench side. This is our schematic way of using those APIs that connect clinical side via SOAP and Puma with the bench side to do things like diagnostic, prognosis, identifying biomarkers, and so forth. So this is our prototype principles. Look, if you ask me about the schema for SOAP, this is a schema of SOAP. You see, everything is connected to a problem, the Puma schema, and that Puma schema connected to problem list. What is a Puma schema is a SOAP case, and SOAP case is subjective objective assessment. What happened at the end can vary. Vital signs can vary. Labs tests can vary. So it's an elastic, flexible way to define a schema at the upper. You see what we done, the connectivity between SOAP and whatever electronic healthcare record can be harmonized in this way. You see, we can produce international patient summary. We can connect to FHIR. We can connect to the bench side. So that connectivity via Puma will help us to do many things, like polypharmacy. That means if a patient been taking medication that it could go against him, because especially with elders, prognosis. If I want to know the future of that case, what kind of prediction? Other indicators. You see, that is you see, if I push data like genomics and other omic data set, I can know many things that is related to genetics and other proteins and other behaviors. So we are now in the process of connecting to lots of omics data set and to answer things that we couldn't answer at the bedside in the right way. So that connectivity let us to achieve lots of things, and we are using a lot of technical things like microservices to do that connectivity and micro front ends. I have to speed up because my time limit is 20 minutes, and I approaching the end. Of course, these are the front end, micro front end for the patient, for the physicians, and this is how we look at cases as a graph when we look at how patient one, subjective, objective, or how many patients, what are my plans to every patient's everything. I can look at them into a graph things. I can do lots of things, knowing if there's inappropriate prescription when a patient have many encounters. So this is the case of polypharmacy. You see, we have many other targets and I prefer to end